Hey guys, what is up? Welcome back. So, in the last few videos, we have done quite a bit, right? We're working on this products.go file. We worked on products repository, and we worked on price.go. Okay. So products.go has these three things remaining. So what I'll do is I'll just quickly finish that up. So head over to application and products.go, and what we have remaining here. So yeah, one thing you have to remember is that products service has repo and read model, two things, right? Now new product service, this function that's out here, it takes the repo and read model, two things that are required, right, to create a new product service. And repo is of type products.repository. We have already worked on that on repository.go file. And read model is of type product read model. So we'll say product read model. Okay. And then, you know, since this is a new product service function, it's going to return a product service. And that's what we have said, it returns a product service. And we'll say in return product service and just repo and read model. Right, so this function just returns a new product service based on the two values it will receive for repo and read model. And all products is a method of type product service, and it returns products.product, where product is the struct, products is the package, and this means it's a slice, as in there are multiple products that will be here, and they can be categorized using the struct that we have defined on our. There could also be an error that will be returned from this function. So we'll return s dot read model dot all products. Okay. So now this file is like almost complete apart from the importing bit. Like we've not imported the right files yet. So now since this is out of the way, I want you to focus on two things. One is that this repository needs to work with something, right? And all that logic for saving and for getting things by ID is going to reside in this file called memory.go. As you can see it has save and by ID, right? These two make sense? We'll have to create it here. So repository is nothing but an interface to talk to your memory.go file. And this is a great pattern. This is an abstraction kind of pattern. So whenever you work with interfaces, think about abstraction. Abstraction means that when the user, let's say somebody who's working with this file out here, these files out here, he doesn't need to know what's happening at the behind the interface. Behind the interface could be an in-memory database, could be a real database, could be MySQL, could be a different database. Whatever is happening there, the guys working with these files, they don't need to be aware about that. So there's complete abstraction is what you get with interfaces. Okay, you don't have to use interfaces, but I'm just showing it to you like in the advanced tutorials on my YouTube channel, like the DynamoDB one and this one. We have used interfaces quite a bit. So it's a different way of doing things, different pattern. It's a cleaner way of doing things. Many people like it, but also many people hate it. So, but it's something that you'll find in large-scale applications. You will find interfaces implemented quite often. All right. Anyhow, so you have infrastructure in memory.go. So this means that we'll be working quite a bit on this memory.go file, right? So a little bit of work that I want to do here, I'll just do that. So one is that for this memory repository struct, it's going to have products, which is slice of products.product. Okay. So firstly that. Then since like we have memory repository, we want to have a function called new memory repository. just like what we did right now, like 2 minutes back, just what we did here in our products. I think we said, just like we had product service, we had a function for that new product service. Similarly, we'll have a function here called func new memory repository. All right, doesn't take in anything, just returns a memory repository. So you'll return ampersand memory repository. And what's happening here is you're sending an empty slice. Okay, this syntax sometimes confuses users. This is a slice because you don't write anything in here. If you wrote something like 4 or 5 or 6, it would have restricted it and would have made it an array. But this is a slice because there's no restriction on the number of items it could hold. And having brackets after that means that it's empty. Like here you could have something, but it's empty right now. So it's an empty slice that you're passing here. So whereas in this file, right, the way we initialize it was accepting actual values and then initialize it with this. Here we're initializing it with completely empty values. All right. Now function save. Function save is not in isolation. Function save is actually a method which is of type memory repository. And function save again takes in some things. It has to take in something, right? And also has to return something. So when you save something to the memory, you usually come back with an error saying that, hey, I was not able to save something to the memory. So that's why we'll just returning the error from here. So we'll say product to save. Now many people do this, that whenever they save something to the memory, they also return what was saved to the memory. So you don't have to do that because you already have access to product to save. So it's personal choice really. So I'm just going to return an error in that case. I'm not going to say that, hey, this is the actual value that was stored in the database because I already have access to it from product to save. Okay. So you'll save products.product. This is your package products and this is your struct. In case you don't know what it is, you can always head over to your products package and you can see that this is the product struct that you're talking about out here. This is the product struct you're talking about. That's why the P is capital. All right. Now what you can do in this function is you can range quickly over the products that you just received. You received products, right? You can range over those products. And the correct syntax, as you know, to range over that is for I, P. This is the iterator and this is the value. So whenever I teach range to anybody coming from a JavaScript background, I tell them that it's a combination of for in and for off loop from JavaScript, wherein you get access not only to the iterator, but you get access to the value at the same time. So you can access both. So it's basically combining the for in and for off loop of JavaScript. So here it's p.id is equal to product to save.id and product to save. So product to save is what we are basically keeping track of and seeing that in the memory repository, which is M, you're saving those products one by one. You're ranging over them and saving them one by one. Here you'll say m dot products is equal to append m dot products comma product to save, and you'll return nil. Okay. And all products, right? All products is again a struct method. So all of the methods here are struct methods belonging to this struct. Make sense? And the struct has products, right? So this is why you're able to access m.products here. So you'll say, so it'll accept some things and it'll return some things. It's Since it's all products, it only makes sense that it's going to return a slice of multiple products, right? And where have we defined the products? We've defined that in the products package as a product struct, and this is going to return a slice, but it could also return an error. So here you'll say return m.products, and by ID. How do you get a product by ID? So this again is not a function in isolation, it's actually a memory repository struct. So it'll say ID and products.id. Now to return something by the ID, return a product by the ID, it needs an ID to be able to search that in the memory. Once it does that, it returns a particular data point. And the data point in our case is not a slice, it's just one singular particular product. And where have we defined that? We have defined that in product, comma, products, comma, product. Products dot product, I meant. So in your memory, you'll have your products. Now, one thing that you may have noticed by now is that we are not using a database. We are just storing it here in the memory repository, which is just a struct. So we are storing all of that in Golang, in a struct, right? It's as simple as that. So we're just going over those products and finding, going over that memory repository and just finding that. And when you're adding something also, we're just adding it, saving it to that particular memory repository. We're not saving it to a database, okay? But because we have an interface, whatever is happening at the background, right now we're saving to database, to a memory location inside Golang, or saving it to database. The guy working with these files doesn't have to really bother. The guy working with those functions or those files doesn't have to bother what's happening with the database or the memory side of things because of the interface, okay? So interface always means abstraction. Range m.products, and then if p.id is equal to id, we'll have %p, just returning one particular product. If the products are not found, you'll just say that there's an error called product error not found, right? This one, product not found, error not found. This is the one that you just called. Make sense? So everything that we're doing is kind of tying with each other now. Everything is making a lot more sense. And this is where I want to end this video. And in the next video, we'll continue with the rest of the things. So this file is almost complete. This file is complete. We don't have to touch this file now anymore. We'll be working on our interfaces, hopefully, in the next file, in the next video. So now you're very clear, right? This is the main file around which everything is kind of working. And to satisfy the conditions for this file, we're kind of building along things, right? Along, like we built our price.co file, we built our repository and products files, our memory file to store data, and now we'll work on the interfaces. Thank you for watching. I'll see you in the next video.